I think we all have a pretty good understanding of what it means to dissolve a solute into a solvent. We do a lot of these things when we're cooking and on a daily basis, but we need to get a little bit more detailed for the sake of this class. So there are three ways that we can increase the rate of dissolving, or to say it in a fancy way, dissolution. And again, these are all things that we do when we cook. The first one is to increase the temperature. When you increase the temperature, the molecules are going to move a lot faster, and they're going to space themselves out more quickly. By moving quickly, they're going to diffuse and space them out quicker. So temperature, again, is one way to increase the rate of dissolving. Another one is surface area. So for example, let's just say we had a sugar cube versus granular sugar. A sugar cube only has 6 sides and they're flat, and the water, if we're talking about water being the solvent, can only dissolve from the surface to the inside. It always goes from the surface in. Whereas if you have granular sugar in fine grains, the surface area of each of those little crystals is exponentially larger collectively than the single cube. So if you have more surface area, the granular sugar will dissolve much, much quicker than, say, a sugar cube, which is also why a lot of medicines are in liquid forms, like, say, a gel cap versus, say, a hard pill. The hard pills take a long time to dissolve, so they're going to be very long acting because they take a long time to dissolve from the surface in. Whereas if you have a gel cap or something like that, then once that exterior dissolves, then the liquid goes into your bloodstream quite quickly. But again, it's all about surface area. The next one is called agitation. Another way to say agitation is to basically talk about stirring. So again, when we cook, we often stir. And the reason we do that is because it moves things around. Think of like temperature. Temperature, again, by moving the molecules faster, they're going to spread themselves out more evenly, more quickly. And again, that will speed up the dissolution process. Same thing with agitation. When you stir the pot of your sauce, you're moving things around in a similar but a larger scale than, say, temperature, which again is doing the exact same thing, but on a smaller molecular scale. So those are the three ways you could increase the rate of dissolving. For a solid, you would increase the temperature. For a gas, you would decrease the temperature. We'll get to that later. Surface area, again, if you crush something into a powder, it will dissolve so much quicker. And in fact, if you make it into a liquid, it'll dissolve even faster. And of course, if you stir it. So those are the three factors to increase the rate of dissolving. The next thing we need to talk about real quick are some terminology. So there are 3 types of solutions. And what I mean by that is how concentrated are these solutions? So you all are very familiar, say, whether you're making Kool-Aid as a kid or sweet tea or whatever it may be, and you're adding your powder or your sugar or, you know, some sort of solute into your drink. There's a fine point where you can add more, let's just say sweet tea. You could add more sugar, you could add more sugar, but once you get to a certain threshold, if you add any more, it just won't dissolve. You could stir it, you could stir it, you could stir it, you could stir it and agitate as much as you want, but it will not dissolve. What you have reached is what's called saturation. A saturated solution is you have dissolved the maximum amount of solute. So you are fully saturated when you have dissolved the maximum amount of solute into that solvent, and it just will not hold anymore. Now you could put more into it, but it will not dissolve. It'll go and settle straight down to the bottom, much like a suspension. Now, if you are under that threshold, we say that is an unsaturated solution. So basically the way I like to say it is you could dissolve more. Okay? The solvent would be able to suspend and dissolve more solute. Okay, so if you're thinking again of our analogy of sweet tea, this is an unsweetened tea or a very lightly sweetened tea. You could add more sugar if you wanted to, and it would dissolve, but it is just, we're somewhere underneath that. Now, on the opposite extreme, we have something that's a very rare case, and it's very difficult to make. I have never been able to make one, but there are some good videos on YouTube about it. And these are called supersaturated. A supersaturated solution is basically where you have been able to dissolve way more than you should have been able to. It's a highly unstable state. It's very difficult to do, but it is possible. And one example is sodium acetate. You can superheat the solution, get it really hot, and then you dissolve actually above the threshold, above saturated. Now, like I said, this is unstable. So if you add just a little bit more, it'll crystallize and the whole thing will come out of solution and it just solidifies. It's pretty cool looking. I'll try to show you guys some videos in class. But this is diluted, or excuse me, dissolved. I'm going to say beyond the maximum. Okay, like I said, this is rare and this is highly unstable. It is very difficult to make. This is not something you could just, throw together in your kitchen like, I'm going to dissolve more than I should be able to. Well, if you can't do it, then you shouldn't be able to do it, right? So those are the three types of solutions. Now, if we've added too much, like say our sweet tea, and we just have like a mountain of sugar, of just gritty sugar on the bottom, that's not super saturated. That is just oversaturated. Oversaturated means you just added too much and it's just not going to dissolve. Now that's different again from a supersaturated, because a supersaturated, you have been able to dissolve it. It's just really unstable. I mean, you barely bump that thing and it will just solidify real fast because it's way beyond the threshold of where it should be. Like I said, it's very difficult to do. Moving on, it says, what happens if a solute crystal is added? Okay, when we say a crystal, we mean like a grain, say a grain of sugar, or a grain of salt, or something like that, right? We're just going to add just a little bit more. What's going to happen to it? So if we added one more little tiny grain or crystal to a saturated solution, it would settle to the bottom. It would just fall to the bottom. It would not dissolve, right? We've already reached the maximum. It's just going to fall to the bottom. It's not going to dissolve. Now, if we have an unsaturated solution that add more, it would dissolve because, again, we are below the threshold. We are able to dissolve more. Therefore, if I add a little bit more, well, it's going to dissolve. Lastly, if I have a super saturated solution, an unstable, temporarily dissolved super saturated solution, I add just one more crystal, like I said, it will solidify. It will become, I totally misspelled that. It will completely come out of solution. Everything will come out of solution. Okay, it all just falls out of solution. Again, we are unstable. We are way beyond what we should be able to dissolve. And we just add a little bit more and the whole thing just falls out of solution. It's pretty cool looking. All right, let's see. Okay, moving on to a little bit more terminology. The next thing we need to talk about is something called dilute versus concentrated. Now, I know you guys have heard these words and you probably have used these words. So if we are a dilute solution, that means we are basically unsaturated. I'm going to just go ahead and put it this way. We are unsaturated with a low concentration, right? With a low concentration, we could definitely dissolve more. Again, to continue with our sweet tea analogy, this is like an unsweetened tea, very dilute. There's not very much sugar in there. Or if we're talking about the tea itself, it's just very watered down. If you have like a soft drink, like a big soft drink from say, like a gas station and all the ice melts, then the soda will become increasingly dilute. It typically doesn't taste as good because it's getting watered down. Therefore, again, is less concentrated. It is more dilute. That means, again, the concentration has decreased. Now, if it is concentrated, that is the opposite. It is necessary, well, it could be saturated or very close to it. And it's going to have, well, I'm going to say high concentration. It's kind of ironic since I'm talking about the word concentrated. You should never use the word in its own definition. But basically, again, if it's a concentrated, we're going to have, think of like, say, you boil off, I'm trying to think of a good example that you do in your kitchen. Well, as things like evaporate out of a sauce, the sauce becomes more concentrated. Salsa, for example, if you leave the salsa in the fridge for a long time, some of the water will evaporate and it actually becomes increasingly acidic, increasingly spicy, and becomes increasingly concentrated. That's just an example because I love salsa. But dilute and concentrated are related, but they're kind of the opposite. If you're talking about a drink, again, you want it in that fine line of where it is to taste, where you like it, whether you like it dilute or concentrated or somewhere in between. But again, they're just referring to an amount of concentration or how strong something is, or how much solute there is relative to its solvent. Okay, so under what conditions can a solution be saturated and dilute? That would be when it's very cold. When it's cold, and we're talking about a solid here, then the amount that you could dissolve is actually quite low. So it would be dilute, but saturated. Now, if we're talking about a gas, I alluded to this earlier, if we're talking about a gas, it's the opposite. You would want a very hot gas, then that would be saturated with the gas, but dilute. Again, I'm going to get back to the gases versus solids here in a little bit. So I'm going to say for a solid, I'm just go ahead and write this down for you guys. For a solid, that would be high temp. And for a gas, that would be a very low temperature. Okay. All right, the next thing is miscible versus immiscible. Miscible means they can mix. Okay, not too surprisingly, able to mix. Now, if you guys remember, like oil and water are immiscible. They are not able to mix. You could shake them as long and as hard as you can, but eventually they will settle out because oil and water, water is polar, oil is nonpolar. They are immiscible. They do not bond. They do not interact. They will eventually separate, whereas miscible means they can be mixed. Okay, this is not exactly the same thing as a solution. Doesn't necessarily mean dissolved, but it does mean they are able to be mixed. Okay, so don't confuse soluble and miscible. Soluble refers to its ability to be dissolved. Miscible literally just means they can be mixed. Okay. All right, guys, there's some more vocabulary for you for Unit 9. Again, thank you for watching, and we're about to move on to some solubility curves.